Ashley. I think we got in a plane crash.
Yeah. My arm's broken, I think.
Well, let's go see if we can find anything to wrap up your arm with. Oh. There's something from the crash. I think that should be good for now.
Yeah.
Okay, let's try to see if we can find anything from the plane crash. What's that? Is this a compass? Oh look, it's a compass. So it looks like the road is due east of us. I'm assuming it's going to take us about 2 days to get all the way to Mrs.McCurdy's house since we're on foot.
Well, we should find food now before it gets dark.
Yeah, I'm really hungry.
All right, I'll look over here, you look over there.
Okay.
Look, I found food in this tree. Good. Look right there.
Oh, yay.
Food. Find a drink. I think this stuff up there. With water. Look, that was first part of Newton's first law. That was an object in rest stays in rest until acted on by an unbalanced force.
So the water bottle was the balanced force, and I was the unbalanced force putting it in motion.
Yeah.
Good enough. I'm hungry. Okay, well that was good, but now I guess it's time to start moving.
Yeah.
Hey Ashley, do you ever wonder if we're actually in motion or if everything's just moving around us?
Well, that's what reference point is like. A reference point is for.
What's a reference point?
Like if I was in motion, I could use this tree as my reference point. Like you see how it's in front of me now?
Yeah.
Well, as I move, it goes behind me. So that's my reference point, and I'm in motion.
Does that mean that it shows your change in position?
Yeah.
Oh. Oh gosh. Now we have to cross this river to be able to get to the other side of the forest.
Oh no.
Hey Ashley, look at this leaf.
Oh yeah. What about it?
Did you know that this leaf demonstrates buoyant force?
Why?
Because the leaf is less dense than the water, and the buoyancy is pushing up, has an upward force equal to gravity with its downward force on the leaf, which makes it float. Now we better cross this river. Okay, you cross first.
Okay. Whoa, that was hard. Be careful.
What was that?
I think there's a bear.
I don't see anything.
Hey, Ash!
Let's measure our velocity. Okay, Sam, I guess we better find a place to set up camp because I'm getting really tired and we need a rest before it gets dark out. This looks like a pretty good place to set up camp, right?
Yeah, I'm pretty tired. We should probably make a fire or something like that.
Yeah, I'm really cold. What do we need?
Something dry, something we need
rocket from the plane?
Yeah, I do actually. I have 3.
Okay, good. Perfect. Okay, so you find some sticks and I'll find some other things.
Okay, so you get the brush and I'll get like the sticks.
Okay.
Brush kind of stuff. A whole lot of sticks over here, so.
Okay. I got leaves. Leaves will catch on fire, right?
If they're dry, they'll catch on fire.
Well, they look pretty dry.
Great. Okay.
Sticks. Oh. Ow.
Come here. Isn't this a chemical reaction?
Yeah, because the physical the physical properties of the wood is interchangeable after we lit the fire. This is also an exothermic reaction because the heat is being released.
But it's also endo, isn't it? Because our skin can take in the heat.
Absorb the heat?
Yeah, like absorb it.
Oh, yeah. Sliding friction.
It's also sliding friction.
Whew, I'm getting kind of tired. How about you?
Yeah, but we don't have a shelter. We need something to build.
Didn't we find a tarp near the plane wreckage?
Yeah, I think so. Should we go look for it?
Yeah.
I'll look over here.
Oh, there it is.
Oh.
Found it. Oh shoot, there's holes in it from the plane crash.
Does that mean we should still use it?
Yeah, it's better than nothing.
Should we hang it over this tree or something like that?
Yes. Okay.
Does this look good?
Yes. Just like that. Yeah. Okay. You ready for bed?
Guess so.
Oh my gosh, is it raining? Thank God for terminal velocity.
What's that?
Terminal velocity is what stops rain from eroding Earth and not destroying us.
How?
Terminal velocity is an upward force that goes against the speed of gravity. So, instead of the rain coming down at 9.8 meters per second, it comes down at a constant speed with a net force of 0.
Wow, that's interesting. Well, since it's so cold, we should probably get some sleep until the storm wears off.
Let's see if it's cold enough that when I spit, my liquid spit will turn into solid ice. Whoa! It is so cold outside that my liquid spit was able to turn into a solid ice cube. That means that the temperature outside is to freezing point. That's amazing!
We should probably start going.
Yeah. Let's pull out the map and see how much farther we have. Where's the compass at?
Right here.
Okay, so we're right here. So the nearest road, all we have to do is cross a river and walk a few feet, and then we should be at the nearest road, and then we have another 34 miles until we reach a town where Miss McCurdy lives. So, easy enough, let's go. Look, there's the river.
Oh, yeah.
Look, there's rocks so we don't have to step in
compression.
Isn't compression a type of force?
Yeah.
Okay, so now we have to go this way towards all those rocks.
We should move this rock. I don't think we're going to be able to get up there without moving it.
Yeah, because I don't want to step on a rock that doesn't look as stable as all those and end up falling.
Yeah, let me try moving it. I can't move this rock.
You know what that reminds me of?
What?
Newton's second law.
Why? What's that?
Because Newton's second law is force equals mass times acceleration. So that rock has more mass than you, meaning that you would have to apply a greater force to the rock that has more mass.
Maybe if we both push it, it'll work.
Let's try. Yay, we defeated Newton's second law. Yes. Now let's move this second unsturdy rock. Well, that one was easy because I have more mass than that rock, meaning that I can move it with less of a force than we had to move the big rock that has more mass.
Who knew?
Oh my god, I see the road! That's crazy! Ah! Ow! It hurt! That reminds me of Newton's third law!
How do you come up with that?
Because Newton's third law is, for every action, there's an equal and opposite reaction, meaning that we were two objects in motion and we ran into each other, and our forces, since they were going opposite, they were equal and bounced us opposite directions.
Who knew?
Oh,
Ow.
yeah. Okay, let's get walking. Look at this water bottle, Ashley.
Yeah, what about it's floating?
Do you know what that means?
No, what?
That means that that water bottle is less dense than the water.
Didn't know that.
That's why it's floating.
Oh my gosh, I thought it would sink.
Who knew?
Not me. Hey, do you have a sweatshirt?
Yeah, I do. But I was gonna use it.
No, I want to use it.
I want to use it.
No.
I want to use it.
I want it.
I want it.
This is tension, isn't it?
Why would you think about that now?
Because we're both pulling it apart, and I don't know, it just came to mind.
So, that means that you're pulling a certain amount and I'm pulling a certain amount. Is that why it's not moving?
Yeah, it's equaled out. Equal force.
Awesome. But I want the sweater.
Too bad, I want it. You can stop. Sammy, we're finally here. Miss McCurdy, Miss McCurdy. Answer. Open the door. Oh my gosh, we crashed in Alaska. We've been trying to get to your house for 2 days.
Really?
Yeah, can I have a drink of that water?
What is this first?
You mean the condensation?
What is condensation?
Oh my gosh, condensation is when the hotter gas hits the colder surface, then it makes the water bottle sweat. It's condensation.
Here you go.
It feels like a perfect night to dress up like hipsters and make fun of our